this time on the laboratory, we're going to work on this. This is a little resin toy, kinda, that it's electrocution chair. Anyhow, it's not working correctly. It's got batteries. It's the switch. The switch doesn't. So the switch is going out. This is supposed to be one of those test buttons, which has been cut. I'll probably end up replacing it, so you can remotely turn it on and off. But we're also probably going to upgrade it. We have a speaker here, noise detector here, light sensor there, and then you just have the off-on switch. When you go to the back, it's the light and noise. When you go to the front, it's the test. Also, what we're going to do is, this has a fiber optic right here, and this one's missing. And it's got two itty bitty LEDs in here in his wrist area. They're not the greatest, so we're probably fix the switch, try and fix the fiber optics. Right here is the seam. It goes all the way around, it steps up, and it goes right here, comes back down. So this back can be removed. And we're going to see about upgrading the fiber optics in here. Upgrading the light and the fiber optics, since this one's still intact and this one's broke off. So, but you'll see what I mean in a second about how dim these lights are. They illuminate more of the plastic than they do of the fiber optic or the resin. So, turn this guy back on. Light's coming back. And if you saw, just the orange on this side and the orange on this side with a little bit of white right here, that's the light trying to shine up this fiber optic, and it's not so good. So my plan is, besides fixing the switch and fixing the test lead, which just unplugs like most do, I'm putting a new one on with a button, which I have one around here like this. Let's see if this one works. No, I think the end's too small. Yeah, this end is too small. See the size difference. But putting something like this on it, which I have several of these, so I'll go through and see if I have one that's the right size. So we'll replace that. My plan was to try and replace the LED in here and maybe put one up here by opening this back, drilling a hole if it's not hollow, and trying to get a light fished up in here, and then run the wires down to the where it's soldered in the bottom. So, and this has 2 screws there and 2 screws here. So I'm assuming this whole bottom lifts off that way. You can see the seam around it. I do not see any glue. So, well, it's not a test, it's a try me, but or the test it. And we'll see what we can do and upgrade this for the person that owns it, and then get it back to them. So stay tuned for some electrifying excitement. Alright, well, let's take this thing apart now, see what we can do to fix the switch potentially here and upgrade some lighting. So, first thing I'm going to do is remove the 4 screws. I'm probably going to leave the batteries in the battery compartment. I don't see any reason to unscrew them at the moment, unless there's a hidden screw in there. Screws. It can shrink. Shrink. All right. Well, it looks like I might have to take the batteries out. There's potentially screws underneath it. It won't come out because the mechanism's still attached to the guy up inside, up in his chest area. So I'm going to go ahead and pop these out here. No, screws come in from the top. So the mechanism, as you can see in there, is attached diagonal with 2 screws that come down, which makes it really miserable, as well as the arm that moves back and forth is attached with 2 screws that come from the top down. So I'm not quite sure how they got this in there. There are Molex connectors to unplug everything. There's a bank of them right in here. You got your speaker and your sound sensor, this metal plate. And then your light sensor is right here, and it's actually attached to the back. This is the actual tip of it right there between his legs. There's a lot of wires in here for such a little toy. Well, his clothes are glued down right here, his shirt. The legs are part of the resin. It looks like this top piece that goes up here in his chest, which covers his shoulders right here, I'm squeezing, might be accessible if I separate the glue, looking from the bottom. So I'm going to carefully lift his shirt and separate it from the hot glue. Or maybe separate the hot glue from the resin. Let's see. Yeah, it looks like I can separate it from the resin easier. Hot glue and fabric's always a pain. There we go. No idea how old this is or what manufacturer. I know there's similar ones out there from different companies. I have one actually that's very similar, but it's based on the movie Sin City. So I can't give you any information on this one, as all it says is made in China. So, anyhow, I separated the glue, which you can see right here, from the base. And you can see here's the upper mechanism. You can see there's the shoulder pieces right here. So if you have this and you have to disassemble it to fix something inside, you're going to have to take his shirt off. I can see the screws looking down the hole. His head is held on with a spring right there. And I'm going to take the glue off the spring so I can get it off of the mechanism. The piece of plastic has a small lip that the spring is clipped into. I am currently just trying to pop it out using a small blade screwdriver. There's 2 coils that are underneath this clip. I got the first coil out and missed the second. there's the second coil. So now his head is no longer attached. This top piece does have a clip to disconnect the shoulders. Let's see if I can get this clip to compress enough to pop out. Use a couple or a small pair of needle nose pliers here. Push on the clip and see if it'll go in. There we go. So, if you'll be able to see it, there is a step right here and right here that two coils of the spring go on. And then this goes into his shoulders, and then this is the push clip right there. It goes through the top hole. This has multiple holes, which indicates this mechanism was probably used on different things for different heights. So now I should be able to, voila, pull this out. And then now you get a clearer vision of the bank of Molex connectors right there. Everything's color coded. The red, or should be orange and gray wires on this corner are the lights and the wrists. The green wire goes to the light sensor. The yellow wire goes to the motion sensor, or noise sensor, sorry. And the white, yellow, black, red, and gray wire, which is this big connector, goes to the switch, the battery pack, and the circuit board motor mechanism right here. Also kind of interesting, this circuit board has a touch sensor right there. I think that's kind of interesting. That's usually what you see when you touch and your finger jumps the gaps, and that's what turns things on. They have a lot of wire in here to make life easy. They even put a loop in it to tie up some of the excess, which is rather interesting. And then you have a blue Molex connector on the side here, and that blue one goes to the battery. Yep. Battery, speaker. No, it goes to the speaker, I'm sorry, and the other side of the circuit board. So, I thought I went to the battery. It just looks like it. They just have it looped twice behind. A lot of extra wire. They use a lot of wire. So, I'll show you how this mechanism works, and to reduce the noise, I'm going to try and unplug the speaker real quick so it's not so obnoxious on the camera. It's just hard to get to because it's behind the speaker. I might have it unplugged. Let's pop the batteries back in it real fast. This is my thumb. See how the mechanism works? Little wheel spins. It pivots onto that screw right there in the middle, which gives you the motion. See how it's loose? So, pretty interesting. And no, I can't pull this out far enough without ungluing the speaker. So, I'm going to put this in the off position, and I'll pop out set batteries again, because it's actually really loud when it's not inside of its casing. So, need to get these LEDs out from in there. I want to unplug the light sensor so it's not damaged. So I'm going to unplug it. The light sensor is the green wires, which on this is labeled as CDS on the board. Charles Davis Samuel. Now, see, I'm going to have to chip off some of the glue around these lights. There's a lot of glue in here. I definitely did not want these things to fall out. have to heat them up. Now, if we do, you just got to be careful because this resin plastic is super thin and it will melt. So we definitely do not want to melt this, as this was apparently a gift many years ago. You don't want to damage it. We would like to make it better and make it functional. And they just poured that glue in there. Doesn't help that it's recessed. Well, this might take some time. So the recessed LEDs are up inside of his wrist. This is all one casting, so they're really deep, and you can see how narrow this is in comparison to the pliers. So I can't get a good grip, and I'm just slowly chiseling away at the glue, trying to get it out. Since this might take some time, I'm going to go ahead and just pause it so I can get these separated and get the glue removed from the fiber optic so we can redo this, make it look better. So, if you can bear with me for just a moment while I get this taken apart. We'll go from there, see if the camera will show. You can kind of see where the wires are way down in there. So to give you an idea how deep that is. So you can see I'm going all the way into the wrist area, and it's not very wide. And his hands and wrist, even though it looks like there's a seam there, is just paint. It's actually part of this solid casting. So I'm going to work on this, and as soon as I get it out, we'll be right back. One moment, please. All right, we're back. Dug him out, and while I was there I went ahead and got this separated so the back comes off. So all the holes all the way down into his wrists are cleaned out completely. It took several minutes to get it out. I did not use heat. I just worked on it with the small blade screwdriver and those pliers. I mean, a relatively large portion came stuck to these lights, as you can see there right here. So this was just held on with a little bit of glue right in here. So, and it good to go. The fiber optic that it had, the single piece, it goes all the way into the wrists and goes all the way down through the little hole in the back, but in the top it only goes in about 1/4 inch. And this top section is solid resin once you get past where this lip goes. So drilling it in to try and put like an LED in there might be a little difficult, but we'll still check towards the end. But yeah, you can actually feed this through the wrist and out the bottom. It's just a wide open hole. So, but here it is, close up of everything. There's the lights. I did unplug the speaker finally, so I can turn it on. I wanted to check the voltage. These guys are running at 1.7 volts, the two LEDs. I found some small blue ones I got, which are right here. They look clear. They run at 1.7 as well. They're just not super bright because they're supposed to run at closer to 3. But I was figuring they're small enough I might be able to get them up inside here. If I can find a long, thin drill bit that I can drill a little channel up into the skull. Because this hole at that 1/4 inch is actually in the outer beam here. But the big issue is the switch, and the switch is actually working correctly now. I'm thinking that some of it is there was debris in and around the switch, which is dried glue. This dried glue, and you can see there's some black stuff on the top, worn plastic. Because right now the switch is working like it's supposed to. There's no big deflection. The screw is a little loose, which can cause a problem. So we'll just tighten that up and see if I can tighten this one up at an angle. So the switch is now functional like it's supposed to be. So there it is on normal. And this is try me, so it won't work unless you short out the two contacts. Then off. So I think the problem with the switch was debris got into the little holes on the side. On the side of the switch are some access holes from the assembly process, and we got dried glue inside of it. I think that's what was wedging the switch and causing it to malfunction, since it's now working perfectly. Also, there is dried glue all over the front sensor, right here, or the vibration sensor. Technically, it shouldn't have anything to do with it, but since they do have a hole in the side, I'm thinking that being part of the cause as well. So I think it's just the old excess material breaking down and getting in the way of, well, the mechanical components. The light sensor looks fine. You can kind of see it in there over here. That black little tube with two wires sticking off of it, and then sticks through right there. The light sensor only works when it's in regular mode, not try me. Just like the vibration sensor and noise sensor. And the try me works perfectly. I'm going to put this button on it for him. This little click on button. The end is different, so I'm going to swap the ends. This just has a two forked end, which is made where instead of it having the pins on the bottom, it has two holes as you push it in. So I'm going to modify that. That way it can be used as a try me button, so it doesn't go off every time somebody enters the office. Or you can flip the switch to the other side and make it so it goes off anytime it detects a light or sound change. But the fiber optics, this is really thick. This is standard fiber optic right here. Might be hard to see, it's really thin. And you can see the thickness variation is dramatic. To actually give you a number perspective, just in case you guys out there want to do fiber optics or replace fiber optics. Fiber optics come in different thicknesses. I have lots of different fiber optic, and I'll see if I have something thicker. So we're going to do this in millimeters. So this fiber optic is 1.48, or we'll say 1.5 millimeter. This little guy is 0.41. So there's quite a big difference in diameter. So you can still use this thin stuff, and you can actually twist it or braid it together. Let's turn that off to save the battery. So you get a whole bunch of little strands, and you can twist it into a spiral. Yeah. And you can glue the end with, I use what would be Gorilla Glue, or you can hot glue it. In some of these, this is acrylic, not glass. I do actually have glass fiber optics, old school stuff. You can melt it with a lighter. Don't recommend it. You can also use heat shrink, which Lemax is known for. Unlike the the Stretch and Pull Torture Factory. Sorry. Inside where the lights are for the fiber optics go around the sign on the front, they use heat shrink, and they shrink the wires together, and they stick 2 LEDs in there and shrink it together as well. So there's many ways to take multiple strands and make it thicker, like a single thick strand of this. But I wasn't going to do one thick on one side and multiple on the other. To me, that would be, it wouldn't look right. It just wouldn't. Now, the thing about fiber optics is they only transmit light generally through the tip. So the light goes in over here as an example, and you just see it over here. This piece in the middle you normally don't see. Well, how you can make it so you can see the light is sandpaper. You run this stuff across sandpaper, it makes this opaque, which means that it disperses the light more evenly throughout it. Same with this. This is crystal clear. If it was run across sandpaper, the whole thing would glow versus just the end. And that's why I think it doesn't look very good in here, even in the dark, because the light doesn't travel up through here on the sides. It just shines off the end, which then shines inside the skull, which doesn't do anything because there's no hole for the eyes or anything like that. So I believe they just have some, it was just probably a lower end fun little novelty. And it just would look cool. It even doesn't look too bad with just no fiber optics. I mean, just like this, it looks like a standard electric chair. But since it came with fiber optics and does have the option for lights, we're going to see about modifying this to make, well, fiber optics. So I am probably going to go do the heat shrink method, where I'm going to try and get a little piece of heat shrink. And this thing's itty bitty. And see if I can find one that's going to fit inside this hole, which this one does. And then run some strands, twist it, put on a small piece of heat shrink on the end, and then do it to the other side. That way I can have a thicker piece, and then once I have them together, I can then just run sandpaper across them. So let's start the process. What I first do is cut this down. I don't need a piece this long. It will be too obvious to see. Actually, let me see if I have black. It'll blend in better that way instead of yellow. There you have it. Small piece of black. Really small piece. And we'll get some fiber optic that I have lying here on the bench from an old toy I took apart that was full of fiber optic. Just trying to match the diameters. That's really close. I got all but one or two strands in there, so we're just going to feed them through. Kind of fidgety stuff. There we go. And like I said, this is just a little bit of an upgrade modification to make this look a little bit better. If this is not something you want to do, you don't have to do this. You can skip forward. But you can use the same principle to upgrade other things, whether it be a rehab house or fix the fiber optics on the Lemax houses that run the fiber optics, or even the Mr. Christmases. I noticed there's a lot of them out there that run fiber optics. Not a whole bunch, but there's a lot of individual pieces, especially like Christmas trees and small lights around the house. So I have the fiber optics in here, the quantity I want, so it's about the same diameter. You can use a lighter or heat gun to shrink it. And because this is acrylic, it also melts some of the fiber optic. Actually, it melted all the fiber optic. Apparently got too hot too fast. But, and now we're going to do the other side. They do make the heat shrink in clear. I just don't have any this small in clear. All my micro heat shrink is in black, yellow, blue, red. So and if you don't have heat shrink, besides trying to melt it, you can also well, you can use the glue, or you can just twist it and electrical tape it if you want. I'm going to redo this end, so I'm just going to cut these off. It's also what's nice about fiber optic, it cuts really easy with a pair of snips. I don't think I've done any fiber optic repairs on this channel yet, or modifications, so this might be the first. I know I did replace the light bulb for the fiber optics in the Leamax Stretch and Pull Torture Factory, but I didn't modify the fiber optics. I just fixed the LEDs. There's a close-up of me repairing it since it melted so much of it the last time. Now the end of it that melted a little bit is too fat to fit in the hole, so I'm just going to trim off the pieces that flared out. And that should fit back inside here. It's not pushed in all the way, but it does fit. So I'll use this hard one as a reference for length. I'm going to go a little bit longer because of how much room is in this wrist. So I can go a hair longer and deal with a, if I make a mistake, I have a little play. So trim off, discard. I think we got them all in there. Yes. Nope. Missed two. So if you don't get them all in, you can just fish them through. I slide the heat shrink down a little bit and then feed the ones that missed in, which there was a few. Now, I personally am a fan of fiber optics. I like fiber optics. I think it's really cool. I know back in the 80s, fiber optic lamps were really popular, where they have like a flower, glass or plastic thing that would rotate. The fiber optics would change colors because it had a little pinwheel, and I have lots of those little pinwheels in 12 volt and 120 volt and 240 volt. I've always been a fan of fiber optics. I've tried putting fiber optics in different things. Not super successful because of the amount of time it takes to run every strand, but fiber optics I do enjoy. You can make some really neat stuff with fiber optics. When I worked at the telephone company for a long time, this is the stuff that they would transmit signals through. Everything was done through fiber optics. So here we go. Here's the new arc. Here's the old one. I'm not too worried about the shape of the arc because, well, this is super flexible. And if you're concerned about twisting it and it won't stay, you can put a very fine dab of like the Gorilla Glue in the strands and then twist it and hold it for a few seconds. It'll hold it tight. We might end up doing that when we put this in here, because I am actually afraid of drilling into these skulls. I was hoping that these would be hollow and not backfilled resin, kind of like it is at the bottom, so it clips on, or how this is completely. And it would be kind of neat to make the entire fiber optics light up with a blue light in the top, a white light in the bottom, so the electricity color blends the white and blue. Because if you ever watch lightning, it's white, but at a distance it changes colors. When it's up close and personal, it overpowers your retinas. So I thought it'd be kind of neat to do a multicolor. But unfortunately, I don't think I'm going to be able to do it very easily due to the resin, and also this is a curved back. Drill bits don't like to curve. So sticking it in, there's a chance I might poke through the back of this. And like I said, that's not my goal to ruin it, just to make it look and function better. So I'm not going to actually put the lights on the top as much as I would love to. I'm just going to put them in the bottom and then sand these so they're opaque, so that way the light shines more efficiently through it. So just to give you an idea how the fiber optic actually functions, we're going to use the LED tester, the blue light I was going to use. And I'm going to get it closer to the camera so it's easier to see. So if I shine it through here, you can see the light on the end. Actually, it's picking up the light right here. So there we go. The glow you see on my fingers and stuff isn't actually the fiber optic. That's the light bleeding around because the LED is bigger than the fiber optic itself. So I'm going to try and close it off. You can see the light. There's nothing in the middle, just at the base. So if we sand this, the whole thing should light up. So you can sand it, you can scrape it with a knife sideways. I would do each strand individually if you did it that way, because it's kind of a process. So I'm going to just do a little bit of sanding. Don't have to be super abrasive. I actually made a fiber optic lighting system for the top of the car a year ago, a year and a half ago, and yeah, it was kind of a pain because I used these small strands and I used hundreds of them, maybe thousands, to run across the top of this car, and then lit it up for a Ghostbusters car. For when the first time the movie of Afterlife was supposed to come out, and it came out 2 years later, or a year and a half later, because of COVID. So I'm going to do this one, and then I'm going to do another one, but I won't do it on camera because you see how much time it takes. If you do have to do something like this, and it's multi-strands, it's probably easier to do all of them separately. But I know on certain projects, it would take you hours or days, depending on your patience level. Now the glow that you see here that's blue is from the sanding. It's not bleeding through the fingers. That's the thing about fiber optics. If it's perfectly clear, you don't get the blue or the white or whatever color. It only comes through on the end. But now with the thing sanded I got a couple that are still clear because they didn't get hit with the sandpaper, but the majority of them are now coarse and you get some light. So I'm going to now spend some time, finish sanding that, sand these, relume them, and then I'll glue this back on since I can't drill the hole in the top due to I don't want to damage it. Like I'm saying, it's not hollow in there. You can see the solid plastic. And once we do that, we'll glue these lights back in with the new fiber optics. We'll put him back together, screw the base in, put his shoulder piece on, make sure it works, and then glue his shirt back down, cover it all. And I was also considering, most electric chairs have a little wire that comes off the top of the helmet and goes around, so it not only goes through your wrists and it goes through your head and chest. So maybe to make this look a hair more realistic is coil up a little piece of black wire and route it around and maybe put a dab of hot glue on the back to hold it. I just don't remember how violently he shakes because you don't want the wire to impede the motion of the mechanism right there. But at the same time, I want it to look a little bit more realistic because I think that would add a little flair to this older tabletop piece. So we shall return in just a moment with hopefully fully sanded fiber optics and this reassembled, and then we'll get that back in. We'll test the lighting, see how it looks in the dark or low light, and go from there. So we shall return. Alright, I got it back together. I got the new fiber optics on both sides put in. I got his head or shoulder piece back on with the spring reattaching his head. Put the bottom back in. That way we can test it. Here is the new Tri-Me cable. There's where I repaired it. So looking at it, his head bounces violently. Now in Tri-Me mode, the other sensors are disabled, so it's not going to turn back on unless I press the button. You can see how far his head moves forward, which means if we want to do a cable to imitate the electric cap, it's going to have to be quite long. So I have a piece of black wire. It's got a little bit of red on it because it was part of that zip cable. And I'm just going to use a pen and wrap this thing tight. Like so. So we can make a nice coil. And then I'm going to use a little bit of heat to relax the wire. Not enough to hopefully melt anything or burn my finger. While it's still warm, I'm going to tighten it one more time. And that should be enough to hopefully stop the head banging from ripping the wire out. So we're going to try it. So I'm going to put a little dab of glue right there. And I'm going to bend this over into a small hook so I get a little bit more surface area on the helmet. And then we'll glue this behind the point on the chair. And we'll see how this works. I guess while the glue gun heats up, I'm going to kill a set of lights. Because I haven't even checked the fiber optics to see how they glow. So let's do that while the glue gun heats up. Right off. camera's not going to pick it up so well. So you get a little bit of a glow going up. They're not the brightest lights, but you can see a very faint glow in person. Camera, I think, only picked up a little bit here at the wrist, but it does actually have a very faint glow that travels up. It would have been neat to try and do the skulls, but I don't want to damage this. I don't know if there's any replacements out there. What's nice about using the hot glue is if he decides he doesn't want this on there, you just peel it off. Whereas if I use something like super glue, it would damage the helmet. Alrighty. I don't know if you can hear the snoring, but my dog is sleeping at the entrance to the laboratory. So let that cool down for a moment before we try it. It's already peeling. There we go. That little glob seems pretty solid. Let's give her a whirl. No, it didn't pop off. That's good. But with the wire, in fact it is wire, let's see if we can bend it up a little bit and make it look a little bit better. The electric chair version I have actually has a little piece of wire as well. That's super stupid glue. I'll put a little bit more right here. Get rid of the glue strings. Let that harden for a second. And if we do it this way so you can see his face. So the wire is staying because it's long enough. I didn't want to make it too short because this guy has a huge range of motion. As you can see, his head can go all the way down here. You can see how it stretches the wire out. And over here, which isn't so bad. But I was more concerned with the forward head banging than the backwards or the side to side. So, but I think if it coiled up a little, it's not too bad. And yes, the other sensors do work, so I can flip it out of Try Me, put it in regular mode, just dropping it on the table. And then sometimes there's certain noises. And let's turn it back off. So This was given to me because it wasn't working right. It had debris in the switch, which stopped it from functioning. Figured we'd try and upgrade the LEDs, which unable to without potentially damaging this beyond repair right in here. But we were able to make 2 new fiber optic bars that are braided, individual strands that are sanded, versus the flat, solid piece of plastic, which is right here. Little cable, which if he doesn't like, he can just pop off, because that's the great thing about hot glue, just comes right off. And yeah, so it wasn't a super difficult repair. A little bit of modification. The fiber optics was time consuming to rewrap, and then of course if you're going to put the spring back on his neck, I'll recommend, if you do have something similar to this, not this piece, but something with a spring like that, the small jeweler's tweezers, those pliers work great, because you can grab the first coil, pop it over the 2 clips, then grab the second coil and pop it over the 2 clips because of the teeth. Whereas tweezers, being smooth, it just slides. But that doesn't just go for this. A lot of things that have springs or spring tension, little needle nose pliers work really good. So, not a very exciting video, kind of a I'd say boring one, but gives you an idea of some of the custom stuff you can do with just random things you might have lying around. Like I said, this came out of one of those Chinese, this fiber optic I'm pointing to, generic Christmas ice skating rink type houses, and all he did was peel the fiber optic out when I threw the rest of the stuff away. I just bought the house at Goodwill for like 99 cents for the parts inside, so I had parts for future projects. So this isn't something fancy. This is just cheap stuff I got at the Goodwill. You can actually buy fiber optic in loom or bundles online, such as eBay or Amazon, or just hit the Goodwill, and you can usually find around the holidays things that have fiber optic in them that you can scavenge, as an example, like I did here. So, and then the wire, it's just wire coiled up in a little heat to help it retain its shape. And then I re-glued in the LEDs up here using hot glue. Reattached this. I use dabs of hard glue or Gorilla Glue, because of how violent he shakes. I don't want the softer glue, being hot glue, to cause the backing to break off, because this thing does violently shake, and of course it walks itself across the table. So yeah, cleaning out the switch, adding new fiber optic, adding a little coil to his helmet. That's all. So, till the next one, thanks for watching, where we do more repairs, most likely on Lee Max and other things. But every once in a while we get these random little pieces that need a little TLC as well, so they can go back into the collections they come from. Have a good one.